One of the inferring elements in material science and nanotechnology is carbon, which can introduce in the following molecular types: graphite, fullerenes, and nanotubes. Figure 1 shows the molecules of fullerenes, C60 carbon nanotubes, and graphite, which can be considered in the form of graphene sheets arranged in a hexagonal lattice. Figure 1. C60 fullerene molecules, carbon nanotubes, and graphite. Among these carbon forms, the well-known is graphite, consisting of single layers of carbon atoms which are stacked with hexagonal carbon sheets on above of each other. Single sheet representing the hexagonal structure was obtained in an exfoliated form in 2004 by Novosel and Game. Also shown that one of these single sheets, the so-called graphene, can be transferred to another substrate and the electrical characteristics can be measured. Graphite, like carbon nanomaterials, consists of sp2 hybridized carbon atoms located in a hexagonal lattice. Their difference in different sizes and shapes on only some uncommon properties are similar. In the history of graphene-like materials, they have been known and studied since the 1940s, but obtaining single isolated graphene and measuring its electric characteristics was experimentally difficult and was considered almost impossible. A detailed report was made in work, and the history of obtaining and characterization of graphene was shown in table first. From the history, we know the Boehm, who invented the naming of graphene in 1968. In this work, 1962, demonstrated the existence of single graphene. In 1962, Boehm exfoliated a jaw with heteroatomic contamination, where the electric conductivity was significantly lower compared to pure graphene, which was obtained using the Scotch tape method. On the basis of a historical time scale for the synthesis and the characterization of graphene, it should be noted that all works except that Boehm were observational and did not describe the distinctive properties of graphene. Thus, according to the historical scale, in 2005, Novosel and Gay made the first report on obtaining a single layer of the graphene using the Scotch tape method without heteroatomic contamination, and which describes its distinctive unique properties. Table first, timeline of individual events in the history of graphene for its preparation, synthesis, and characterization. We will know that ordinary pencil contains graphite, and when the pencil is moved on paper, the graphite is exfoliated into several thin layers of graphite, the so-called graphene sheets. That is fairly simple use of a pencil, which contributes to the splitting of graphite. Graphite shows that the complexity is not the manufacture of graphene structures, but simply isolation on large individual sheets in order to investigate its unique two-dimensional properties that Game, Novosel, and their employees succeeded in. Fullerenes were discovered by chemists in 1996 and represent a new form of molecular carbon, C60, that contains 60 carbon atoms assembled in a circle shape resembling a soccer ball, which consists of 20 hexagons and 12 pentagons that allow surface to form a sphere. Another formal carbon structures were known since 1993, nanotubes, which represent a bound, quasi and one-dimensional shapes and formed from twisted graphene sheets in the form of tubes. Carbon nanotubes, like fullerenes, have hemispherical ends, and the electronic and mechanical properties of single-walled nanotubes are almost similar to graphene. Graphene nanotubes, depending its layer of wells have the following sizes. The diameters of single have 0.8 to 2 nanoamperes. The diameters of multi 520 nanoamperes, may to 100. Also, conductance of semiconductor walls of nanotube depends on lattice orientation relative to the axis, which has the name chirility.